This is Unit 1 review. This is the final page, numbers 32 through 36 even. All right, so number 32 and 34 here, they ask you to solve the absolute value inequalities and graph the solutions. Okay, so when we solve an absolute value, remember there's two answers. Since it's an inequality, you have to check to see if it's an AND or an OR problem. Both 32 and 34 are going to be OR problems because they're greater than. All right, so when I solve this, I have x plus 12 is greater than 36. And then remember we have x plus 12 is less than negative 36. When you make it a negative, you have to switch the inequality sign. All right, so you subtract your 12, you get x is greater than 24. Over here, subtract your 12, and you get x is less than negative 48. Okay, now the reason why it was important earlier for us to talk about whether it was an AND or an OR problem is when you do this, you have to make sure that your graph actually matches that. So greater than 24, that's an open circle to the right. Less than negative 48, that's an open circle going to the left. And that is what an OR problem typically looks like. Okay, AND problems have to overlap in the middle. This is not one of those. All right, so for number 34, we're going to first have to add that 5 to the 8. We need to make sure we get the absolute value isolated by itself. So we're going to add 5, add 5. So when I do so, I have the absolute value of x plus 2 is greater than 13. And now I take that x plus 2 and make it greater than 13. And then the second part is the x plus 2 is less than negative 13. Again, same idea. You're going to have to switch the inequality sign when you make it a negative here. Over here, I subtracted my 2 to get rid of that 2. I get x is greater than 11. Same thing over here, subtract your 2, you get x is less than negative 15. Go through, and when you do so, you have a negative 15, you have an 11. Open circle going to the right, open circle going to the left. Again, that's typically what an OR problem is, and problems have to be in the middle. All right, last problem here we have number 36. This is a word problem. All right, you're going to Phillies game this spring. Tickets cost $31. Popcorn is $4.25 per box. You have $60 in your wallet. And it's going to ask us here now to write an inequality, or write an equation that models this scenario. Okay, and to solve the equation, how many boxes of popcorn will you be able to afford if you want to spend all of your money? All right, so when we go through and we do this, we have to remember we have to spend $31 on the ticket. Okay, so you have $60 total to spend. So whatever it is we're going to spend here, we're going to have $60. Okay, $31 for my tickets. That's one ticket that I'm going to buy, so that's going to be $31. I have to account for that. All right, and then I have $4.25 per box. We've talked about this. Per means multiplication. We don't know how many boxes of popcorn we're going to buy. We want to figure out how many boxes we can. That's part B. How many boxes of popcorn can you afford? So it's $4.25 times by the number of boxes, which we don't know. We normally use X in math to describe something that's unknown. And then plus the $31 for the ticket, and that's equal to 60. So that's my equation. Okay, and in fact, really it should be an inequality here. It can be less than or equal to 60. I can spend less than that much money or up to that money. It says if you want to spend all of your money, that means we're going to try to spend as much as we possibly can. So now I need to solve this. I'm just going to keep going from up here. Subtract my 31 from both sides. I get $4.25 times by x is less than or equal to 29. And then we need to get rid of this 425, so I'm going to divide both sides by 425. When I do so, this cancels, and I'm left with x has to be less than or equal to, and when you do it, it comes out to be 6.82. Well, you can't buy 0.6 or 0.82 of a box, so it's really got to be 6 boxes is how many we can buy, and there'll be a little bit of money left over then.